Hello. Yes, we welcome you back to our new channel, Natural Sciences Grade 8 and 9. That's the name of the channel. The statement reads, consider the two diagrams below showing leaf friction and answer the questions that follow. So we are having this diagram. This is diagram A and this is diagram B. Then the question says, identify the type of reflection in A. Okay. Yes. How do we classify A? Okay, let us look at what we see in A. We are having a parallel beam of light striking the surface, and it is reflected as a parallel beam. So what type of reflection is that? Yeah, we call it specular or regular reflection. Yeah, then we come to B. Yeah, what type of reflection is shown in this diagram? Let us describe what we see. So here we are having a parallel beam of light striking our reflecting surface. And what do we see? It is dispersed into different directions. Okay. So what type of reflection is that one? We call it diffuse reflection or irregular reflection. Yeah, then we come to this question. It says that identify which reflecting surface is 1. Smooth. Okay. Yeah, which of the reflecting surface is smooth? Answer is A. Yeah, what we observe in A, the regular or specular reflection, is because of the surface being perfectly smooth. So a parallel incident beam results into a parallel reflected beam. Okay. Yeah, and which surface is rough? Is B. B is rough. And that explains why the rays are reflected in different directions. So it's B. Yeah, then we come to this question. It says that describe what type of image is observed in A. Yeah, during specular or regular, what image do we observe? Here we observe clear image. Yeah, then we come to B. What type of image do we observe in B? Here we observe blurred or unclear image. Yeah, then we come to this question. It says that our eyes see objects because of reflected light, which bounce off the objects. Okay, this is the situation we are looking at. We have the bulb. The bulb sends light to the object. Then light is reflected off the object into our eyes. It is then that we can see. That's the reason why when you switch off the light, you can't see, because there is no light which is bouncing off the objects. Okay? So we come to this situation. It says that what name is given to the idea that light travels in a straight line? How do you refer to that idea that light travels in a straight line? We refer to it as rectilinear propagation of light. Okay, then we come to this question. It says that the diagram below shows the formation of image by a pinhole camera. So this is the pinhole camera, this is the object. And then we say, complete the diagram above by drawing the rays showing how the image is formed. Okay? Yes. How do we accomplish this? Here you have to know that what happens actually is that the rays come from the object. They come and pass through the hole, and what is behind is the film where the image is formed. So how do we show this diagrammatically? This is what we do. You draw a ray coming from the top of the object, like that, going through the hole. And then you draw another ray from the bottom of the object, but going through the pinhole, like that. And then what do we do next? We indicate the image. Our image is inverted. So this is what we have. Inverted means what is on the top of the object, this side on the image is the bottom. And what is the bottom of the object on the image? It is the top. So indicate direction. So they are coming like that and like that. Yeah, then we come to this question. It says that state what happens to the size of the image when the camera moves one closer to the object. Yeah, what happens to the size of the image when you move the pinhole camera to the object? The size of the image will increase. Okay, then to further away from the object. So when you move the camera away from the object, what happens to the image size? The answer is it will decrease. Yeah, then we come to this question. It says that the principle on which the eyes see an object is similar to what happens in a pinhole camera. The two are very close, the pinhole camera and our eyes. Okay, so this is what we have. We have the object here and forming this image here. So we come to the question. It says, name the part labeled A, B, and C. Okay. So what is A? A is this inner lining of the eye. Actually, it represents the part on which an image forms. So what do we call that lining? We call it retina. Yeah, then we come to this part labeled B. What do we call it? We call it lens. Okay. Then we have this part C. It branches off from the retina and it proceeds to the brain. So what do we call that part C? We call it optic nerves or optic nerve fiber. Yeah, then we come to this question. It says that give the function of each of the parts labeled A, B, and C. Okay. Yeah. What is the function of part A? This inner lining of the eye. The function is that it contains light sensitive cells, and it's where the image is formed. Yeah. Then B. What is the function of B? B is this part. We said is the lens. So what's the function of the lens? The lens serves to focus the light. Focusing is some kind of bringing light to one concentrated area. So that's the function of the lens. Yeah, then we come to C. Yeah, what's the function of C? We said C is optic nerve or optic nerve fiber. And what is the function of optic nerve fiber? This transmits impulses to the brain so that the image can be interpreted. Yeah, then we come to this question. It says that explain why we don't see an inverted image. Yes, remember we have an upright object and our image is inverted, but we don't see the image inverted. Why? Okay, the reason is that our brain believes that an inverted image is the right image. So, when the image is inverted on our brains, it's correct. When the image is upright, then it's abnormal, it's inverted. Yeah, that is that. And with that, I would like to thank you for your time. The channel is Natural Sciences Grade 8 and 9 with me, Richard, here. Yeah, we urge you to subscribe, to like, to comment. Yeah, we believe we are the best. So stick with us. You won't regret. See you next time. Bye-bye.